So in this video we are going to make the arrow move smoothly, but first I told you that I would be looking at the lighting as well. So we can ask ARKit to directly, so this I can completely remove it, and I was really just adding this to see what it looked like in here. However, if we go back to the view controller and head over to the view did load, we can get ARKit to update lighting for us automatically. So all you have to do is call the scene view and enable auto enables default lighting, and you set this to true, and that's all you need to do really to get some lighting in your scene. Now I like to control a bit more what I'm doing usually with the lights. I think they're very useful and very difficult to master, but in this project we don't really care that much about having a perfect light. So this is more than enough for us, and that's all we need to do. Okay, so also, yes, so why am I doing this? It's also because you may have seen that if you look at the arrow from the front, it looks okay, but if you look at it from the back, so if you start to move around and look behind you, the arrow is still there, but it looks very dark because the directional light is in front of it, and that's not good. The default lighting will prevent that. Okay, so now that this is done, let's take care of the smooth movement for the arrow. So the idea here is that we are going to take the last 10 positions. So here, every time the renderer updates, which is about 30 times a second, I think, we are creating a new position and we are assigning this position to the arrow. Now, what we can do to make this smooth is to average the last 10 positions. And to do that, I'm going to create a new function, and I'm going to create a new variable as well, which is going to be my positions. So here I've got positions, and this is going to be an array of scn vector 3. Yes, so these, and I'm going to initialize this with nothing inside. And in here, so instead of arrow position equals position, what I'm going to do is to add my position into those positions here. So positions, this one. And then here we can append a new element. So scn vector 3, which is good because that's what we created here. So position, okay, and here what we want really would be like an average position, right? So we need to create this, and first we would have to, so let's comment this out. Here we are going to create an array of the last 10 positions, so last 10 positions equals, and here we are going to return, so we'll take our positions, this array of positions, and as you know, this is going to be, 30, we'll increase this amount, this array by something like 10, 30, 10, 20, 30 per second, so it keeps updating very, very quickly. What we want here is to get the last 10. So if I do suffix like this, and the maximum length that I want is going to be 10. Right, now if we look into this last 10 position here, we don't actually get an array of SEN vector 3, we get an array slice. Okay, so let's copy this here, and here what I'm going to do is to create a new function that's going to take those last 10 positions. So if I start this function, get average, so average position, okay, and I'm going to get this from positions, which is going to be, so here you can paste the array slice of SEN vector 3. Right, so in here we are going to need an average x, which is going to be a float, and the same for y and z, so I'm just going to copy and paste here, so this is y and this is z. Okay, so also what I will want to do is to get the average position will return one position, and it's going to be our average position. So here what I'm going to return is an SEN vector 3. Hope that makes sense. And now we can calculate the average x, y, and z from the last 10 position. So very simply, I'm going to loop through the positions. So for position in, so that's going to be in my positions here. What we're going to do is to add on all of these. So here I can call my average x and do a plus equal position dot x. However, this is actually not going to work, so I'm going to set this to 0 from start. Otherwise, you see it says that it can't convert the value, etc. So let's just initialize those floats with a 0, and in here I'm going to make the sum. So here we've got y and y, and here we've got z and z. Okay, so in here now all we need to do is to return our SEN vector 3, so it's going to be an SEN vector 3 make, just like this one here, and we are going to average those out. So here if I take, so let's create our SEN vector 3 make. So for the x position, I'm going to get average x and divide this by the number of positions. Actually, let's just get this count directly. So let count equals positions dot count, and this is going to be a float so that we can make some calculations between this float and those floats here. So now we have this, we can just our sum of average x or position x is now going to be divided by the number of x positions that we have, and that's going to be our average x. Good, so we can now copy and paste here, and that's going to be y, and this is going to be z. Excellent, so we now have our position, our average position. So now the arrow's position is going to be get average position from our last 10 positions. And I'm using count here because well, at first it's not going to have 10, it's going to have less than 10. So just to prevent any error, we are just going to calculate these counts basically, and then divide here directly by the number of count. Okay, so let's have a look and see how this looks now. Okay, so if I start to move, you can see how this is now a lot smoother. It does not move as quickly as it used to, and if I go down or up, that's a much smoother transition. And you can see how the light is estimated as well by ARKit. So this is all working really well. Let's have a look. If I put a dot there and here and there and there. Okay, so yeah, this is working. This is really good. It's time to do some measurements now. So in the next video, I'm going to show you how we can measure the exact distance between 2 points.